Hello, what's up? I brought you a new video. I hope you will enjoy it. Bye. Hello, we are going to speak about structural geology, especially about faults. The faults normally occur when brittle rocks fracture and there is an offset along the fracture. The faults is classified by the movement. One of the first one is horizontal, the second is vertical, third one is oblique. There is two major fault types. Number one is dip slip faults. Normally the motion is parallel to the fault dip. And the second one, strike slip faults. The motion is parallel to the fault. Dip slip faults may produce long, low cliffs called fault scarps. As you can see, there is two parts of the walls, the foot wall below the fault and the hanging wall above the fault plane. Types of dip slip faults. Two dominant types, normal faults and reverse faults. And there is a special type from the reverse fault is the thrust fault when the angle is less than 45 degrees. Types of dip slip faults. Normal faults. The hanging wall moves down relative to the foot wall. The normal faults, larger scale normal faults are associated with fault block mountains, basin and range of Nevada, for example. Normal fault bounded valleys are called grabens. Brine grabs. Graben. Normal fault bounded ridges are called horsts. As we described before, the types of faults are dip slip faults and normal faults. Horst and grabens. Due to the tensional stress responsible for normal faults, they often occur in a series, with adjacent faults dipping in opposite direction. The basin and range province of the western United States. For example, in Nevada, Utah, and Idaho. Rift Valley formed by extension. This is a half graben. As you can see, there is a series of normal faults, half grabens, and down there is a graben and horst. You can find also this normal fault, the graben and horst, in the Gulf of Suez of Egypt. Types of dip slip faults. Reverse faults. A hanging wall block moves up relative to the foot wall. Reverse faults have dip greater than 45 degrees, and thrust faults have dips less than 45 degrees. Thrust faults, Special case of the reverse fault. The hanging wall block moves up relative to the foot wall as we described before in the reverse fault. But the thrust fault characterized by a low dip less than 45 degrees. Sometimes the thrust fault is over a major distance. As you see in Nevada, in South Nevada, there is a thrust fault. Also another one in West Las Vegas. What drives a thrust belt? Old timers thought that decollements beneath thrust belts dipped away from the elevated hinterland, and therefore gravity sliding was the main mechanism. Strike slip faults. Dominant displacement is horizontal and parallel to the strike of the fault. Types of strike slip faults: right lateral and left lateral. Strike slip faults. Strike slip faults transform faults. Large strike slip fault that cuts through the lithosphere accommodates motion between two large crustal plates. Joints. Joints are very common rock structure. They are fractures with no offset, result from tectonic stresses and rock mass occur in parallel groups. Significance of joints. Chemical weathering tends to be concentrated along joints. Many important mineral deposits are emplaced along joint systems. Highly jointed rocks often represent a risk to construction projects. Geologic structures and oil. Oil and gas are concentrated in the core of an anticline where they are trapped by an impermeable layer. As you see, the salt dome here, around the salt dome you can find the oil here and here and there and there. And above this salt dome, there is some faults where we can find some traps. Normally, this is the anticline where you have a trap which contains the water and oil and gas. Not every case like this. Sometimes you can find water only, sometimes oil, sometimes gas, sometimes nothing at all. But if the environment is suitable for presence of oil and gas, you will find it like this.